This is Patricia Townsend from Washington State University, and I'm welcoming you to the Wednesday Hardwood Biofuels webinar. This is produced from Advanced Hardwood Biofuels Northwest, and funding comes from United States Department of Agriculture. This is one of the USDA NEPA AFRI-CAP programs around the country. And today we have two speakers coming to you, Bruce Summers from Greenwood Resources and John Paselius from Case New Holland. If you're just joining us, please answer the poll questions that are on the right side of the screen that tells us who you are and your level of familiarity with bioenergy and harvesting bioenergy in particular. I want to start off by telling you just a little bit about the project, Advanced Hardwood Biofuels Northwest. Advanced Hardwood Biofuels Northwest is a consortium of university and industry partners that work together in the Pacific Northwest to take hardwood hybrid poplar and turn that into drop-in fuels and also bio-based chemicals. One of the interesting things about the project is that it looks at all aspects of feedstock development for these biofuels. So we have a team that works on feedstock, another team that works on conversion, another team that looks at the sustainability of the process to look at how this is going to affect the environment, communities, and then also the economic effects of this. We have an education team based out of Oregon State University and the Agriculture Center of Excellence at Walla Walla that are working to prepare a workforce for this future industry. And some of the students graduating from those programs, we expect that they might be looking for jobs someday, either at Greenwood Resources or at Case New Holland. And then we have an extension team that's based out of Washington State University, which I am a part of. So I see today that most of our participants are either from academia, about 50% of them are from academia, and then we also have a large suite of participants that are from business and industry. So just for those of you that are just joining us, I want to go back to this screen right here so that if you know how to go under meeting and see the audio setup wizard so that you're getting good sound for the webinar. If you have any questions or anything while the webinar is happening, you can type into the chat box on the left side of your screen, and we will be answering questions primarily at the end of the webinar. So now I'm going to turn this over to Bruce Summers and John Paselius from Case New Holland. So the title of today's webinar, just a bit of a screen delay here, so thank you for your patience. Harvesting short rotation poplar for bioenergy. And so we have John Paselius from New Holland, and also we have Bruce Summers from Greenwood Resources. And so I'm going to turn that over to the two of them, and they will be giving a presentation, and then there'll be plenty of time at the end for questions and discussion. So I'm turning the mic over to Bruce and John.
Hello, this is Bruce Summers from Greenwood Resources. I'd like to thank everybody for participating in the webinar today. My involvement within the program is due to my responsibility with Greenwood Resources as being the harvest manager. We have 4 AHB demonstration plantings throughout Washington, Oregon, Idaho, and California, in which I have been involved in the actual harvesting of those plantations. I'd like to introduce John Paselius. He's an innovation technology manager, and he has been intimately involved in the development of the biomass harvesting head, both in Europe and in the United States, working with State University of New York on willow, as well as with Greenwood Resources on poplar. I'll move on to the next slide. It's basically just a presentation context, giving the history of the CNH Forage Harvester, the development, where poplar fits in, the AFRI AHB demonstration sites, be it Jefferson, Hayden, Clarksburg, and then also we'll have a recap on the harvesting that has been completed at Boardman, and this is The next phase, the next stage, it's been a harvest of 3-year-old coppice material. On the right, you'll see an engine load map. This kind of details some of the data that we can collect via the CNH equipment, and John will be talking about that further in the demonstration or further in the webinar. At that, I'd like to hand this off to John.
John, this is Patricia. We can't hear you.
Is this any better? Okay, good. Off to a better start now. So I'm going to spend the next few minutes talking about our 130 FB coppice header and a little bit on the Forage Harvester. Talk about how the project got started, some of the different testing that we've done with the harvester, and a few bits of the information on the specs of the harvester. When we first heard about the coppice opportunities, we had two logical choices within our portfolio of equipment to work off of: our Case IH cane harvester and the New Holland Forage Harvester. We ended up, as you all know, I think, we've gone with the Forage Harvester. One of the main reasons is because of the throughput and the ability for the Forage Harvester to get across rough terrain. We started our work right around 10 years ago with Dr. Volk and his team up at the State University of New York. And in 2004, our first attempts were with the older FX model Forage Harvester and a non-roast sensitive corn head. We had a moderate level of success with that configuration. The key thing we learned was that the Forage Harvester looked like a pretty good vehicle to use as our core for this kind of work. In 2005, we switched over to a head that was that came out of the UK, CRL Limited, and we got that set up with a lot of help from the CRL people and Dr. Volk and his team on the FX. And we were getting much closer to something that was going to work for us and we hoped for the industry. So in 2006, we continued on with the FX and the CRL head, which you can see on the left-hand side of the screen. And then in 2007, we converted the CRL head over to the current FR series Forage Harvester, which had just been introduced. You can see in that picture on the right, one of the reasons four-wheel drive was chosen. Our sugarcane harvester doesn't see much snow conditions. So some of the base components of the head, actually let me back up for a second. The CRL head worked nice. It worked quite well on the FX Forage Harvester. When we moved to the FR, we had much more capacity and capability with the FR Forage Harvester. And so at that point in time, we decided it was a good opportunity for us to develop our own CNH header. And what you're looking at now on the screen is some of the base components for that head. And where possible, we took some of the most important components, such as the gearbox, from off of our shelves and that were part of other products. And so we did tap into the sugarcane harvester for its gearbox that's used to drive the header on the sugarcane harvester. Some of the saws that you can see in the bottom of the screen, we've gotten from the wood industry. That was one of the things that actually we made big improvements once we got working with the Greenwood people. Some of the rolls, the feed rolls, came out of the Forage Harvester, and our gearboxes are other components that came from off-the-shelf products that we have. You can, I'm not going to go through all of these. You can see some of the specs on the header, the different speeds for the saws, the rotating towers that bring the stems in, the paddle wheel that will help center the stems or the trees as they're cut and bring it into the forage harvester. Everything is controlled from the cab. We can adjust the speeds to either be synchronized with the ground or vary it on the go. The base unit, the forage harvester, the majority of the models that people would use in this kind of an operation require no modifications at all. On some of the smaller harvesters, I see somebody asking about sound. Am I still coming through? I hope you can hear me. Yep, okay. So the base unit on some of the smaller units, the 9050, 9060, there are a couple of factory installed options that need to be included with the forage harvester, but for the most part, the base unit's a standard unit. The configuration that we use for the cutter drum, there's several configurations available. We use the 2x8, and so that's 2 sets of 8 knives on the cutter drum, and that will give us a maximum length of cut of approximately 1.5 inches, 33 millimeters. And I think Bruce can correct me if I'm wrong, but for most of the work we've done with the poplar, we've usually gone for about a 3/4 length of cut. The forage harvester family meets all the tier emission requirements now, and the family ranges from 450 up to 825 horsepower. The machines that we've mostly used in this project, the 9060 and the 9080. The 9060 has 550 continuous horsepower, peaking at 590, and the 9080 is 640, peaking at 685. And the reason I mention that is that power map that you saw in the beginning, and so I'll come back to the power requirements later on in the presentation. So after a couple of years of testing with our internal group and collaborators like Tim Volk, Dr. Volk, we started getting out with public demonstrations and working with public groups. We've spent a lot of time both in the UK and in Central Europe, where there was quite a bit of willow activities going on. So in Belgium in 1990 or in 2009, the UK, we were quite active, and then also in the March 2009, we brought the harvester out to Boardman, and so we did this. This was our first real attempt at working with poplar, and we had nice introductions and knew each other, the Greenwood people, Bruce, and Mike, and some of the other guys there. But this was our first attempt at working with poplar. Down in the lower right-hand corner, you can't see the readings on that tape very well, but that was about a 7, almost 8-inch stump, and the Greenwood guys keep pushing us harder and harder for the bigger wood, but we do have our limits, and that's really a little bit past our limit. But again, so this was our first real attempt at poplar, and so now what I'm going to do is turn it back over to Bruce, who's going to tell us why poplar.
Well, why poplar? The program had essentially been developed using a short rotation woody crop willow, which is smaller. It has more bark to wood ratio, which is somewhat problematic for conversion into biofuel, but works fine going through conventional combined heat and power boilers. Why poplar? Poplar is the fastest growing tree in our temperate region. It has excellent chemical conversion properties, and we're able, through our genotype selection program, really work within families to get more sugars, more material. The vegetative propagation also leads to the ease of cloning, allowing us to rapidly multiply select genotypes. You can see a 1-year-old stem next to one of our employees. Poplar biomass is suitable for biochemical conversion. So if you look at the slide on the right, you'll see we've got various crops, mostly agricultural crops, corn, stover, wheat straw, switchgrass, and then hybrid poplar. And what we focus on is the glucan and xylan. And you can see the percentages of the hybrid poplar. If you take the composite of those two factors that provide sugars, the hybrid poplar rates very well. And also you can see the ash content. We have low ash in comparison to the other conventional agricultural crops. The advanced Hardwood biofuel harvest program, we've got 4 demonstration plantings, one in Jefferson, Oregon, in the Willamette Valley, one in Hayden, Idaho, one in Pilchuck, Washington, and one in Clarksburg, California. These are the 4 different regions. They were established. These plantations or plantings were established for the purpose of identifying how different clones grow in different areas, and then how these locations might best suit the infrastructure necessary to produce ethanol and feed that into the current distribution system. Establishment, basically we're talking spacing trees per acre, distance between rows, and the number of stems per row. Boardman, which was established early on, this is not part of the AHB program, but we had developed a demonstration harvest plot there where we basically planted 10-foot wide by 2-foot between trees, and then 10-foot wide by 4-foot between trees. The AHB plantings were at Jefferson, Hayden, and Clarksburg, all 10-foot between rows and 3-foot between trees. At Pilchuck, we actually had a 12-foot between rows and 2.5-foot between trees. A time motion study during all of the harvesting was conducted by Dr. Volk's group from State University of New York. And we have, this is just some detailed process, but there has been basically studies and some reports put out by Mark Eisenby and Dr. Volk. The Jefferson harvest, this was our first harvest. This was conducted in October 2013. The Forage Harvester was furnished by CNH Innovation, both the harvester as well as the operator. Our trucking contractor on the site was Bill Case Farming. And it's you'll note that as we go through the slides that I have included the various contractors, because essentially you have different types of operations in different regions with different equipment. And the concept of developing a biomass program is to be able to utilize a local infrastructure in order to reduce costs. This is a photo of Hayden, and then we're actually driving our trucks through the field. This is the end of the growing season, so we've adapted the timing of the harvesting in order to be able to access the fields with various kinds of equipment that are available on site. You'll notice that the soil is quite a bit different here in Hayden versus what we saw in Jefferson. It's more of a granitic soil, and it has good weight holding capabilities in the winter parts of the year. This is just a quick recap, and it's basically to show that we have different end results based on different clones. Part of the program was to try and identify which clones work best in what areas. And then this is data that came off of the actual Forage Harvester computer system. So you can see the work rates, fuel usage, green ton per acre, green ton per hour. And we've got some substantially high productivity using this type of equipment. This is another picture of Hayden, Idaho, and this harvest took place in 2013 on October, and CNH Innovation provided the Forage Harvester and operator, Larry Hall, and the trucking contractor here was Cannon Hill Industries. Now, in both Jefferson and Clarksburg, we had local forage harvesting contractors who were able to supply the trucks and trailers, or tractors and trailers that they used in their normal forage harvesting activities. Here in Idaho, we relied upon a local contractor who did a lot of forest work, and he had trucks that were really designed to go in the forest environment as well as in the farm environment. Here's corresponding data with different clones and so forth that you can see the different productivities and so forth. They varied a bit. The key to harvesting these demonstration plantations is having adequate layout of the fields, and that means headland, taillands where you can make your turns effectively. Ideally, you'd have equipment staged at each end, equipment being tractors or trucks, where you could basically make your loop and pick up another vehicle to be able to access or to be able to feed into from the forage harvester in each run. We have our best success when you have roughly 4 strips between where you ingress and egress out of a row. And that allows the forage harvester to be able to maintain pretty good speed to have a nice wide curve at the end of each row. The harvesting performance, both Jefferson, September, October 2013, and Hayden in October, the infield effective material capacity, it ranged between 20 and 100 ton per hour. And this increased linearly with the standing biomass. So you've got certain clones are much more productive than others. And when we had those clones, we could reach these very high levels of productivity. One of the key issues in this whole harvesting process is the logistics and making sure you've got the trucks to gather the material at the right time. And about 50% of the monitored time was spent actively harvesting, and the balance was in headland, tailland, and so forth. Clarksburg, California, this is a little bit different environment. What we found is we moved from Jefferson to Clarksburg to Hayden is, like I mentioned earlier, different contractors, different systems. And this was completed, harvest was completed in November 2014. Once again, it was a CNH innovation. Larry Hall provided the forage harvester, and then our trucking contractor there was Joe Avis Contracting. He's a large forage harvesting contractor. He has 20 trucks, and he provided the trucks for the harvesting of this parcel. What is to be noted that this is quote the California system of trucking, in which they have tip-up covers over the beds of the trucks that are always on the left-hand side of the truck. So you always basically blow to the left-hand side of the forage harvester. Here's a picture of just the trucks in the queue. And one of the key things is making sure we have enough trucks available. And then due to the fact you're basically developing a stubble of 1 to 3 inch in diameter, that you cannot basically deviate from the row. You've got to go the full length of the row. I see I had a chat from Marcia. Is this planting designed for bioenergy? Yes. Irrigated? No. And Marcia, I cannot give you the data regarding the clone that produces the most biomass. We'll have to dig into that. Here's a picture of the completed harvest. So you can see the actual tire location of the forage harvester, and the tractor or truck is always 2 rows over to be able to provide adequate distance to be able to maneuver the spout on the forage harvester. Here's Clarksburg. Now this is an important issue, is the product we generate. Dormant season harvesting, where the leaves are off, you've got a much higher ratio of wood to bark to leaf, which has the highest success in conversion. Uh, Growing season harvest, the leaves incorporated within the material, it makes for some pretty dramatic problems with the conversion. I see some more questions here. How high are the stumps after harvesting? 4 to 6 inches. Here's a crew. Uh, you don't have a project that works unless you've got the people to make it happen. This was a very professional crew we had down at Clarksburg. We really need to thank all of these people who worked in these various locations for the successes that we've had. This is a little bit of information regarding the load count and so forth at Clarksburg. We had a 10x3 spacing. It was 41.6 acres. We generated 37 truckloads of material, 254 green ton, and we averaged 32.8 tons per hour, 3.5 acres an hour, and it was 6.1 ton per acre. Recognizing on the first cut, the limiting factor is the speed. We're able to ramp up to a speed of upwards to 5.5 miles an hour. The limiting factor is as we go any faster, we're actually pulling the stumps out of the ground. It would have been the typical process is we do our first cut after 2 years, and that's the establishment cut in order to get the coppice growth. The Boardman Project, this is a part of a State University of New York DOE harvest plan in which we took our existing fields, and in Boardman we have 40-acre blocks. It's irrigated, so we have 10 foot between each drip line. So we planted one 40-acre parcel, was all dedicated, so it was a 10 by 20 or a 10 by 2 or 10 by 4 spacing, and then one was intercropped. And bear in mind that these fields were not designed for biomass harvest, so we had very, very narrow headlands. We had issues as far as the locations of the drip tubes and so forth. But it was a good opportunity for us to really understand what we can grow and how efficiently can the actual forage harvester cut this material. The planting design for the intercrop was we had 20 foot between the harvest trees, and within each of those 20-foot spaces we would have a row of biomass. This is some early information we generated. This is a Field 104 growth and yield data from our Boardman tree farm, and this was destructive sampling. It was 3 years of coppice growth on a 2-year-old rootstock, which would have been 5 total years. And we had destructive sampling inventory, and then we harvested rows, and then we had some various spacings, anywhere from 290 up to 2,200 trees per acre. 2,200 trees per acre is essentially a 10 by 2 foot spacing. And the yield comparison across the stand and densities harvest time that suggested we had an optimal range of 1,100 to 1,350 trees per acre. And you can see on the plantings for the AHB sites, we basically ran about 1,400 trees per acre. We got yields ranging anywhere from 29 to 48 bone dry metric ton per hectare, which is 22 bone dry ton per acre. This is the Boardman, the first harvest. This was a harvest in 2011, November. We used, once again, CNH innovations for the harvesting, and this was the establishment cut. Our trucking contractor there was Nash Contracting, who does work for me on the Boardman farm for our conventional harvesting. Here's a picture of an intercrop in which we're driving down. This is a growing season harvest on field 201, and we're driving down and blowing over the forage harvester into a truck. This is the 2014 Dormant season harvest, and I thought this was, it was cold. It's a good picture showing the actual uh, Forage Harvester as well as the header and how they connect. And then here's the Field 201 Compass harvest. This was a dormant season harvest, November 2014. Once again, the CNH Innovation Forage Harvester. And the trucking contractors, we had to actually retain two contractors there, Nash Contracting, who does my normal harvesting, as well as Craig Scott, who is a local contractor who does corn harvest and forage type work. This is Craig Scott's truck, and once again, this is a conventional truck, live floor bottom, and we blow over the top. And I'd like to note the stump placement. You can see with the staggered stumps, we have to be cautious about our trucks as we drive through the fields, and John will be talking about that shortly. And once again, note the stump placement. When you're the first harvest, you have a individual stump. As the trees coppice, then they basically you end up with a chandeliering and little punji sticks. At this, I'll hand this over to John.
Okay, thank you, Bruce. So the bungee sticks, as Bruce just referred to them, up in that top left-hand corner, you can see one of these sticks that fit that description quite well, or top left corner, I mean. I'm going to talk now about some of the observations that that we made in Boardman, and those bungee sticks caused a lot of flat tires. Bruce could tell you exactly how many, but the amount of delays we had with tire troubles on our support equipment was amazing. It very unfortunate too. The Forage Harvester is set up with forestry tires, and we've been doing that for quite some time. It's been, and I need to knock on wood, we've not had problems with the Forage Harvester. And in the four first cuts, actually the 5 first cuts counting Boardman, when we were out in Boardman in 2011, and then Jefferson, Hayden, Clarksburg, and Pilchuck on the first cuts, we did not experience these kind of problems. But when we got into the more traditional, what we'd expect, production intention chipping, we really ran into the problems of tires. And so that's something in the selection of the support equipment is going to be a key feature. Bruce mentioned the headlands, and again, this is Boardman now. Part of the problem with those tire punctures can be attributed to the layout. We'll find out in Jefferson, Clarksburg, and some of the other sites where we do have better headland area, if it's going to be as much of a problem due to the stooling, or if much of it was attributed to the headlands. I think it's a mix of both. We'll find out which is worse in another 2 or 3 years when we get back to Clarksburg and Jefferson, Hayden, Pilchuck. We started the presentation. Bruce had the engine power curve. We were able to monitor quite a number of different items right on the harvester itself. And so one of the interesting things I thought that was worth showing was the power requirements. The 9080 Forage Harvester that we were using at this time. It was rare we ever came to the power limits of the harvester, but we hadn't been into any production intent type field conditions, and so this is the field in Boardman in November, and you can see on the north end of the field, the upper part of the screen, every place that you're looking at the darker blocks is we're running that engine at 100 plus power load. When I was first talking about the Forage Harvester, I mentioned the horsepower range, and for the 9080 it's approximately 650, 640 constant, and then with the reserve backup it can peak at 685, 690 horsepower. Well, you can see in half of this field we were at peak load, and that's not where you want to run the harvester. When we looked at some of the other layers of data that we were able to collect, time, speed, yield, we are able to measure yield. It was mostly due to the heavier yield up in the north end of the field. That information will be analyzed. We've got a lot of data that we have to look at before we can make strong conclusions and report information on yield. But for this operation and the types of conditions we saw in Boardman, this is probably where we're going to have to go to the next size, bigger forage harvester to hit the types of target throughput that we think are required for economic chips, or we have to be satisfied with a slower ground speed. And so those are the types of trade-offs that we'll be looking at when we come to engine load. I know we don't want to go with lower yields, that's for sure. This is just some very preliminary data for that site. And you can see over on the right-hand side the range in acres per hour, the field capacity of the harvester. In some of the early discussions with Bruce and the Greenwood guys, we were really hoping that we could keep the machine consistently in that 5 to 6 mile an hour type of a range, which would give us the type of somewhere around 6 acres per hour, assuming the logistics are good. I see a question on the diesel consumption. I've got that information. We have that in the maps as well. I won't give you a real precise answer off the top of my head, but that can be as high as over 25 gallons per hour type of a range. And Marcia, I can via email get you some more specific information on that. So moving on, and this is some areas that maybe when we're done Bruce can add into, but the product itself, we've done work in both ways during the active growing season. And this picture is in Clarksburg. You can see the leafier material mixed in with the chips on the right-hand side of the screen. On the left of the picture, you can see how quickly in that California heat that material can start drying up. But the leaf-on harvest, there's advantages that you're not as restricted to time of the year. Obviously, types of conditions that we saw up in Boardman, the types of conditions we see in Willow in upstate New York. But the desire for chips with leaf in them is not so good. So we need to either come up with a way of removing the leaves during harvest, or maybe a market that is more conducive to taking chips with the leaves in them. Here's a shot at the Boardman harvest. This is one of the ways that Bruce is dealing with chips now, is taking it to a storage site and then storing them in the open, reloading to ship. I think Bruce told me earlier that these chips have just been sold to the University of Idaho in Moscow. They're going to be using this for their furnace. This is how the chips were dealt with in the Boardman production runs. Also in Boardman, you can see some of the older chips in the foreground. And this is the live bottom dump truck versus the previous end dump. Different ways of handling chips, and that's probably the key. One of the points that Bruce was making throughout his presentation was taking advantage of the types of equipment that's locally used. Companies like CNH, our good competitors, John Deere, Kloss, none of us make some of this support equipment, and so it really leaves our customers up to the types of equipment that is best suited to their local area. In this picture, you can see 3 different types of support equipment. I think on most of the first cuts that we did, the 10-wheel forage trucks were working extremely nice. After the November harvest this past November in Boardman, and all the flat tires, we're having some second thoughts on that. Maybe the cultural practices of the twin rows, maybe we need to get back to a single row, at least with the poplar. But the tires that we went through on those trucks was really troublesome. In the bottom left-hand view, you can see a very typical mode of operation in forage areas in the northeast. That picture actually is in the Jefferson cutting, though. And the reason we went with the dump truck into the 10-wheel forage trucks was because of the wet conditions we got into in Jefferson, which is exactly why a dump wagon behind a tractor works well in places like upstate New York or Vermont, some of the northeast areas where we get a lot of muddy conditions. The picture in the bottom right is an interesting shot. This is very typical in the northern countries of Europe. And what it is it's a 3-axle powered wagon. I've never seen one of these here in the States, but when you see the types of conditions the farmers are working in Europe, what many of us call mudding a crop out, where you're putting in trenches in ruts over a foot deep. You have to have a powered wagon, and so with either PTO off the tractor or hydraulically powered, the wagons help push the tractor, if you will, right through the field. And then the other advantage in Europe, they typically will have a tractor capable of faster ground speeds than we allow right now in North America, both here in Canada. In Europe, it's not unusual to have tractors that'll get up to 65 kph, 45 miles an hour or so. Now, with that, I think that brings us to the end. Patricia warned Bruce and I about talking too fast, and I know I talked awfully quick during my first few slides, but at this point I'm going to see if Bruce has any additional comments, and then we can open it up for any other questions that anybody might have.
Yeah, I just
Bruce, any follow-up?
Yeah, the one comment I'd like to make, it's been a real learning experience for us, and I've been extremely pleased with the advancement that the CNH and John has been able to make in development of the 130 head to harvest larger material. You know, we still have a little ways to go regarding the support equipment. If we're going to be harvesting in dormant seasons in areas such as Willamette Valley, we're going to have to be looking at different types of tractor trailer configurations in order to be effective in doing that harvesting. I'll hand it on to Patricia at this point.
Thank you. Bruce, can you be sure and turn off your microphone? I'm getting a little bit of feedback. While I'm closing here, if people could type in their questions into the chat box, and then I would ask Bruce and John maybe to scroll through the chat box. You did an excellent job of answering questions as you were speaking, but just make sure that you have covered them all. Wanted to let everyone know that we will be having another webinar on April 22nd. That's a Wednesday on Earth Day. And this one will be focusing on wildlife and biodiversity in bioenergy crops. We're fortunate to be able to have Brian Moser from the Rocky Mountain Wildlife Institute. He's part of the HB project joining us, as well as Dr. Robert Fletcher from University of Florida, who's a specialist on kind of bioenergy and wildlife in the southeastern United States. So they'll be able to find some interesting comparisons between the Pacific Northwest and the southeastern United States. If you could please answer the poll questions on the right side of the screen, we would very much appreciate that. As part of our extension work, we like to keep track in how these webinars are useful, and just wanted to let everyone know that this webinar is possible from funding from the United States Department of Agriculture, NEFA, as part of the Advanced Hardwood Biofuels Northwest Project. So now I'm going to turn the mic back over to Bruce and John, and probably it would be best if Bruce started with a suite of questions, and then maybe he could turn the mic over to John for a suite of questions if you kind of just toggle back and forth. Okay, thank you very much.
Okay, I'll start with kind of the bottom going up with Marcia. You know, again, regarding the yield on intercropping, we're in the process of collecting, collating that data. So I can't give you a hard number yet on that, but we did find that our productivity in the intercropped area was equivalent to what we had in the dedicated portion. Next question to Gary. Could you please discuss ideas for support equipment to move harvested chips from the field to the facility? Ideally in Boardman, our plan is to be able to chip into existing 10-wheel trucks and then haul direct to the facility. This is the Zeochem conversion facility, and that's 10 miles away. So at this point, it doesn't make any sense to have to reload. There's been quite a bit of work done as far as the best means to be able to reload, whether you go into, we have access to some portable conveyors here that you can actually feed into that would load a conventional possibility trailer truck configuration that would carry 30 ton. David, are their best known configuration and time frame production abilities. It's going to vary a little bit depending upon your location. We have good success in areas where, such as Boardman, sandy soil, and so forth, using trucks. We know that the same situation took place up in Hayden, Idaho, with the granitic soil. We have to adapt based on location, based on the local contractors as well. I can't emphasize that enough, because we come into an area with ideas and concepts, and I sit down with the local contractors and we really talk a little bit about, well, what do you have? Here's what we want to do. How do you make it work? Because you don't have a mature industry at this point in time, so it's difficult to get someone to make a capital investment for, say, specific type of support equipment, such as the triaxle powered wagons from Europe. They're $100,000 each. How many acres will the farmer need to make renting, buying a harvesting tractor feasible? I think that's a function of the folks we've been dealing with, talking with. We try and tie in a biomass harvest in conjunction with a corn harvest or another kind of harvest. So it's a function of identifying the best combination of all of these applications. What's the best field shape to allow for efficient harvesting? Well, you need the minimum of 40 foot to make your turns on the end of each field. And ideally, if you've got wagons that hold 10 or 12 ton, you would want to have a length of run that would allow you to fill that wagon. It can go off to be dumped or taken to the location and be able to pick up another truck at the next end. So, what we've tried to do is we've designed these demonstration plantings is make sure we've got adequate headland area, and try and ensure that we don't end up with 1.5 trucks where a truck has to deadhead down to the end of the field to be able to go out for another truck to come in. Let's see here. Talked about the acres. The yield, Marcia, I think I gave you kind of a generality as far as the yield in the intercrop, and we should have more data coming at us here shortly. Cost per ton, this is in response to Claudia, it's going to be somewhat variable. We have to take into account, this is a demonstration project. And so we have multiple clones. Each of those clones have different yield. We have to try and keep those clones separate. So our true, we know that we can actually, on a commercialized basis, harvest at a lesser cost than we can now. It kind of varies as we go from area to area, and we're just in the process of collating what those costs are at this point in time. John, let me hand it off to you, and maybe you can provide some answers to some of these other questions.
Okay, thanks, Bruce. Yeah, Orion's got a couple of different questions here, and so I'll start with your last one, Orion. Just from my experience in ag fields, the trailer behind a tractor sure does give you a lot more maneuverability, and that was one of the things that we saw, was the ability for the 10-wheelers. They just couldn't cut the corners tight. So I do think that the trailer, we've successfully used sugarcane trailers and grain trailers, forage dumps that work quite nicely, and so I think that would limit the amount of flats. And I'm going to keep on. There was another one that I saw of yours up towards the top, Orion, about how much more does it cost for the next size up harvester. that information, unfortunately, I'm in engineering, not marketing. I'd be a much better speaker if I was for marketing. But anyway, that information is available on our website for the what we now call the FR 800 series, which if you're going to be in the heavy yields, like we are seeing at the north end of that, the Boardman field, would probably be the nice machine to have. I'm going to guess you're looking at actually, compared to the 9080, that 9080 had an engine from Caterpillar. In the 9090, we have our own Iveco engine in it, and actually the price difference is not that much, so it's not a big difference. The other question I wanted to mention or comment on was on how much acreage would you have to afford a machine. One of our key efforts with the Forage Harvester and the Coppice Head was to be sure that the Forage Harvester was not modified at all. And the idea is that if you're working with a off-season harvest, like we would see in the Boardman area or the Pilchuck, Northern California, when the Forage Harvester would not typically be harvesting corn forage or hay crops, our customers are always looking at ways of extending the hours per year on that machine to leverage that capital investment. And so I'm not going to even try to tell you how many acres of trees, because as Bruce already mentioned, the yield, what the market is, all of that will play into those kind of calculations. But the more hours you're able to get on the machine, the better off. And so that's where we hope we're able to work in areas that there's corn to harvest during the season. What else? Justin talked about engine load. What see his optimal range? Okay, well, so Justin, your question ties in nicely with the question about the field length and shape too. You want to keep that harvester running as much as possible. Minimal time turning and running straight, and right around the 95%. The machine's designed to run at close to 100% continually. You start getting over 100%, and then we get up into the boost area. So if you're running 90 to 100%, that would be the optimal range. So is there others on here? Orion, would it be available machine to have big enough horsepower though? I'm not sure I understand your question, Orion. But I think the corn harvester, actually the 9080, our new series we call the 9080 is now the 700 series, and the biggest machine, the 9090, I've referred to at 800 plus horsepower. That's the new 800 series. Those machines are typically used in corn and in some of the Southern California areas for the haylage crops. And so, yep, that would work well. So I think probably we caught most of the answers and most of the questions. I hope in good order. I see that we're at the time limit too, so maybe I'll turn this back over to Patricia or Bruce if you have final comments.
Thank you, John. Thank you, Bruce. Thank you to all of the participants today. I'm assuming that both Bruce and John are available for a few more minutes if anybody has any additional questions. I see we had quite a few of them coming in here. So if any of you didn't get your question answered, please just type a note into the chat box and we'll see if we can get Bruce and or John to answer them. Thank you all for attending. These webinars are recorded and archived, and they're located on our Hardwood Biofuels website. So if you would like to see this webinar again, or you know of friends or colleagues that would benefit from this information, please direct them to that. So thanks everyone. Have a good day. Please type in any remaining questions, and I'll see if Bruce and or John have a few minutes if they need to add anything else.
Yeah, the only comment I'd end with is that it's been a great group of people to be working with. Greenwood folks have been exceptional. All the help that we've had in the early development time with the header from the Dr. Tim Volk and his group. It's been very helpful, very good learning experience, and I think we've got something that works for sure in the willow, and we're getting awfully close for the production poplar. Thanks a lot. So Rick, I saw your question up above about the swathing aspen with the CRL head. I don't believe that CRL header does anything different than our head. But let me make sure I'm reading that your original question right. Is the FX45 head still the only option for swath harvesting aspen coppice? So was maybe the coppice laid down in a swath and then the CRL head picked it up? Is that how I understand that question? And if so, the new head that we have does not do a very good job of picking up already down crop, but I think it'd be interesting to give it a try. Okay, the stems are not row oriented. So the CRL, I don't think that gets any wider than our current head. The problem is that the saws have to be as wide as the Forage Harvester itself. Now, maybe with the CRL head on the FX, maybe that was a big enough of a footprint with the CRL header that the FX did not run over any unharvested trees. For our 130 FB header on the FR series Forage Harvester, trying to pull the outside trees into the center and then also cut everything that potentially would be hitting the Forage Harvester itself. We cannot cut just a broad stand of standing trees with our current configuration. Boss has done some work in this area as well, but I know that they're not able to take a broad stand of trees either.
Yeah, this is Bruce Summers. I'd just like to make one kind of an ending comment from a Greenwood Resources perspective is that, John was able to give a really an excellent recap of the development work into the biomass harvesting head. And, Greenwood, we came along a little bit towards the tail end after a lot of work by both CNH and SUNY. But if it weren't for John and his commitment to furthering this process, we wouldn't be where we are today. But I just want to reemphasize that point.
So, Tricia, maybe that's it. I don't see any more questions, and maybe it's time to start working on the next generation. Thanks a lot, everybody.
Thank you.